Section 11.3 is going to talk about another conic section, the hyperbola. So you'll see hyperbolas are pretty cool. You'll see them in lots of different places. Of course, you originally got them as the intersection of a plane and two cones placed tip to tip. I still don't know who's the first one that thought of that. The shape of a parabola is going to be drawn by drawing this rectangle and then the diagonals through that. And then the actual hyperbola itself is just the blue part. It's these two parabola-looking things that face away from each other. You can see the shape of a parabola in a nuclear cooling tower. It's been a hyperbola rotated around an axis. They used to use the intersection of two hyperbolas to find where you are on the Earth with a position system called the RAN. That's been replaced by GPS. Traveling faster than the speed of sound, you're going to leave behind a sonic boom, which will intersect the ground in the shape of one branch of a hyperbola. The roof of Dulles Airport in Washington is one branch of a hyperbola, which is kind of weird. Same architect that designed the Arch of St. Louis, and the Kobe Tower in Japan is a hyperbola rotated around an axis. So lots of places you'll see it. Probably, at least to my mind, not quite as abundant as, say, for instance, the shape of a parabola, but let's have at it. Now, the one thing that I want you to notice about this right away is that it's not an ellipse. And this is a big thing. You're going to have to decide, well, why am I looking at a hyperbola as opposed to an ellipse? So let me ask some guesses. What do you think? Why is this, a hyperbola and not an ellipse?
Subtraction.
The subtraction. Now, I can't tell you what an epic fail it is on an exam to graph a hyperbola instead of ellipse or vice versa. One of them is going to be a lot different than the other. We are still going to follow the same tricks that we had with an ellipse, and that is I'm going to start by rewriting this. Instead of x squared over 4 and y squared over 16, what do you think I'm going to rewrite it as?
2 squared minus 4 squared.
2 squared and 4 squared respectively. Great. Now, just like it was for an ellipse, we are still going to try and find some of these points. It's just that not all of them are going to be vertices anymore. So in the x direction, I'm going to move 2 to the right and then 2 to the left to get a couple points. And in the y direction, I'm going to do similar. I'm going to move up 4 and down 4. But I'm no longer going to play connect the dots with a nice elliptical thing here. Rather, I'm going to say, all right, well, these are going to be the vertices, or not the vertices, but the edges of a rectangle. So you draw this box. It's already been shaded for you. Not that you have to shade it. You don't really need that part. But then we're going to draw the diagonals of this box, this rectangle. Like this. The reason we're doing this is because these lines, these asymptotes, serve as a guide for your graph. Now, because the x squared term is positive, that means it's going to open left and right. If the y squared term was positive, it would open up and down. So let me fit that in here. Let's say x squared over a squared minus y squared over b squared equals 1. That's going to open left and right. If I rewrite things and have the y squared term here, y squared over a squared minus x squared over b squared equals 1, that's going to open up and down. And opens up / down. So just kind of a little thing to keep in mind for you as you're working with your graphs of hyperbolas. When I go through and grade your problems, making sure that they open the right way, that's worth 1 or 2 points of partial credit. So definitely worth something, or definitely something worth paying attention to. Which way does ours open? Up and down or left and right?
Left and right.
Left and right. So what you're gonna do is you're gonna draw a nice little arcing curve through here, and that curve is eventually gonna get close to your asymptotes. So something like that. And something like this. Now, if you accidentally touch it, that's fine. I'm not going to worry about that. But let me take a minute and show you some of the failures on this, some of the things that you would lose a point for. So some of the things that go wrong on this, people do this. They're like, oh, okay, I know it comes really, really close to this graph. So people will kind of like trace it out like this. Now, it doesn't exactly parallel these things. It does have a curvature shape to it. The other big mistake I see is people going all the way to the center. It should go to this point here, not to the center. So people will do something like this, all the way to the center and out like that. So those are a couple of the mistakes, but hopefully you see enough graphs here that you won't be making those. Now, just like we did when we were working with ellipses, we're going to have to find the foci. The foci are going to lie in the center of each branch of the hyperbola. So to find those, we're going to need to calculate c squared again. And just to confuse you from what we did in section 11.2 with ellipses, c squared is now going to be a squared plus b squared. I know. It's like, well, wait a minute. Now you're changing it up? Yes. If we didn't change it up, then we'd end up with a calculation that would put us inside of this box. And if you get foci inside here, there's a mistake. In our case, that's going to be 2 squared plus 4 squared is going to be 20. So c is going to be the square root of 20. Now, square root of 20 is going to be 4 point something. Don't know exactly, so I'll do it this way. 20 raised to the 0.5 power. That's a square root. About 4.5. Okay, great. So that's a distance of 5. So I want to move a distance of about 4.5. So let's see, 1, 2, 3, 4. So about here and about here. So I'll call that F1 and F2. Those are our foci. What coordinates would those have? Jonathan, what coordinates would those have?
It'd be negative square root of 20, 0, and then square root of 22.
Perfect. Now, I'm not really worried about the fact that you could write this as 2 square roots of 5. That's fine. Focus on other things on your exam rather than rationalizing a square root like that. All right. There we go. So it opens left, right. We found the foci, etc. We're looking good. Ready to try another one? All right. Thank you. Diana. In this section, in the last section, it always helps us out to rewrite things as something squared over something else squared. What would I write here? How do we write that?
We do 1 squared and then 5 squared.
Perfect. So we're going to rewrite this as y squared over 1 squared minus x squared over 5 squared. And Dane, which way is this going to open? Up and down or left and right?
Left or right?
So if the y squared term is the positive one, it doesn't have to be out front, it just has to be positive, then it's going to open up and down. Thank you. All right, so this one's going to open up and down. Opens up and down. Let's see if we can't find the coordinates of the foci. So if I want to calculate the foci, I need to do c squared. Marcus, what would c squared equal in this case?
1 squared plus 5 squared.
Yeah, 1 squared plus 5 squared, so 26. So C is going to be the square root of 26. So looking good there. And I think that's it. Let's see. Let's sketch in a graph of something that opens up and down. So remember, it's just going to touch here and just going to touch here. It's not going to touch anywhere else. Now, if you accidentally touch the asymptote, I'm not going to cry. This is a very wide opening hyperbola, and pardon me for any vertigo real quick. I'm just going to repeat that over here. And I deliberately didn't scale this so that we can just throw in our foci. So our foci are going to lie up here and down here. They have to lie inside each branch of the hyperbola. And Jackson, what are the coordinates of that going to be, please?
0 square root 26 and then 0 negative square root 26.
Perfect, perfect. Great. Now there's one last thing that they ask you, and that's for the length of the transverse axis. That's this one. That's that distance there. Oh, wait. Hold on. I think it might be up and down. Give me a second here to think about that for. The transverse axis is going to be the distance between the top and bottom here. So the transverse axis is going to have a length of 2. Length of the transverse. So the distance between this point and this point is just going to be top minus bottom. 1 minus negative 1 is 2. Great. Transverse axis is always going to be the axis that runs through the vertice of each branch of the hyperbola. Nice. And that's it. We're done with that one. Well, let's take a look at the next one. Unless there's some more comments or thoughts on example B here. Let's move on to example C. Now you've got 2 choices here. I'm going to write them both down. This hyperbola is going to open, well, it opens up and down, so is it going to be of the form y squared over a squared minus x squared over b squared equals 1, or x squared over a squared plus y squared over b squared equals 1. Actually, how about a minus there? Which one of these does it have to be? The first one or the second one?
Y squared minus x squared.
Yeah, all right. I didn't share quite unanimity, but there's definitely a preponderance of vote for the first one. So it's going to be y squared over a squared minus x squared over b squared equals 1. Alice, is there any information, either A or B, that you can tell us just right now looking at a hyperbola? Just a quick FYI, in terms of scaling, these are units of 2, so 2, 4, 6, 8, 10, etc. Is there anything I know that can help me out right away?
So A equals 6.
Well, it's in units of 2, so not 6, but
12.
a equals 12. Great. So a equals 12. We'll start out there. That's going to be 12 squared in the denominator. Thank you so much. A squared. So y squared over 12 squared minus x squared over b squared equals 1. Now let's keep going. What else do I know that can help me out? Brendan?
C,
All right, good. And what does c equal to in this case?
13.
Yeah. That distance is c equals 13. C equals 13. And what's the formula, Min? What's the formula that goes along with c? How do I calculate c in the case of a hyperbola, not an ellipse? Yeah, okay. So we'll plug in the 13 for the C and the 12 for the A. And I think things work out pretty good. You might recognize this as a Pythagorean triple. So it's going to be 13 squared minus 12 squared equals b squared. So that's 25 equals b squared. What does b equal? 5. Yay. That's pretty much it. There's your answer. We've got y squared over 12 squared minus x squared over 5 squared equals 1. Nice. There's one other thing I'll show you with respect to this kind of thing. And let's fill in some detail on this graph in order to do it. There's a little shortcut that I figured out. I never really formally justified it. I'm sure I could, but I just never really found the need to find the equations of this asymptote. Now this is just a shortcut. It's not really something you're going to see formally taught anywhere. But if I wanted to find the equation of this asymptote, I could. Now let's see if we can't fill in a little bit more of this and actually come up with that box. If I was going to graph this, then in the x direction to find my box, I would have to go 1, 2.5. So I'd have to go out here and out here. 2.5 units is really a distance of 5. So let's put those in here. In the x direction, I'm going to go a distance of 12. So let's put those in together. There. And then here. And finally here. If I draw in my asymptotes, they should always run exactly through the center of this rectangle. If they don't, that's kind of a double check on your work. If they don't, then look back to make sure that you didn't miscount something one way or another. But these diagonals should cross pretty close to straight through the center of this box. If you notice, each branch of the hyperbola is passing pretty close to those. To find the equation of this, here's my little trick. You can set this equal to 0. And what's going to happen? Well, you're going to solve for y. So this is for the asymptotes. If I had y squared over 12 squared minus x squared over 5 squared equals 0. Let's solve for y. Y squared over 12 squared equals x squared over 5 squared. Y squared equals 12 squared x squared over 5 squared. And now you need to solve for y. What would you do to solve for y? Take the square root. Now, all of these are perfect squares, right? You're gonna end up with plus or minus 12 over 5 times x. And that's the equation of each of these. Y equals, that'd have to be a minus 12 over 5x. And this one would be y equals the positive 12 over 5x. So there would be your asymptotes, or the equation for your asymptotes in each of these. Now that's more than just a little bit of idle curiosity, because in the next one, we're going to be given the equation of the asymptotes, and we need to come up with the actual equation of the hyperbola. So, are we okay with what we did here? It's a little bit of a hack, but it works. All right. Let's try and put it in play with example D.
I don't think we got D.
Well, there was two parts to this handout. They didn't get stapled together. I think a lot of you just took one. So if you want to come back and grab the other one, I actually put a stapler on there so that people grab them and staple them.
Now you tell.
So again, let me go back to this decision. Y squared over A squared minus X squared over B squared equals 1, or the other way around. Which one do you think is the correct one for this graph, keeping in mind that you have vertices at plus or minus 1 and 0? So which one's the correct one? Yeah. No. Yes. Yeah, it is the second one. Good. Sorry. I just immediately thought you were wrong.
You always think I'm wrong.
I said it first, if that helps.
All
I'm
right.
just helping you. I mean, I'm on your side,
Okay.
but I also wanted the credit.
All right. So well done, Christian.
Thank you.
What's
Good job, Oz.
All right.
Copying my answer.
getting caught?
All right. So it has to open like this. And in fact, let's see, x squared over a squared minus y squared over b squared. So all powerful Oz, tell us either A or B here for us.
Why do you always do me like that?
Well, what is,
One.
yeah, there you go. A is going to be this distance right here, distance from the center to one of the vertices, so it's going to be a 1 squared. And we're stuck figuring out what b squared is, but we do have a little bit of a hint. And our hint is that we know that the equation of this line is y equals 3x. Now let me write it as y equals plus or minus 3 over 1x. I'm not worried about the 1 so much as I am the 3. But this in general is going to be in the form of y equals plus or minus b over a times x. And that b is going to be the denominator for y. The numerator of this is going to be the denominator for y. So it's going to be y equals, not y equals, how about b equals 3? Plus or minus, let's see, b equals 3. So my overall equation for this is going to be x squared over 1 squared plus, no, how about a minus, y squared over 3 squared. And that's it. You could draw this out as well. So for instance, if I wanted to graph this, I would draw in my rectangle, which is going to go through this box to this side, this one, and then just sketch in the graph. There and here. Ooh, let's determine the foci as well. That's good practice. C squared equals A squared plus B squared. What's that going to equal for us in this particular problem? Kiki? What should I fill in for A squared and B squared?
1 squared plus 2 squared.
Perfect. So I get 10, so C equals the square root of 10. Nice. Brianna, what would the coordinates be of my foci? Let's call them F1 and F2.
It would be negative square root of 10, 0,
Hmm?
and positive square root of 0.
Perfect. Cool. So there's your foci. I mean, that's everything here for this one. Well done. Let's put it all together and graph one last one here. Example E. It doesn't look like it's in the right position to get started here. So, Amy, what would you suggest I do to get rolling on this example?
X squared over 1 over 9.
Not quite for this one. If I had a 1 on the right-hand side, then I would do that.
Sorry, yeah, I forgot that. Divided by 36.
Yeah, let's divide everything by 36. And I'm gonna go ahead, since that's gonna be x squared over 4, I'm just gonna go ahead and write that as x squared over 2 squared minus y squared over what? Does anyone know? 3 squared. Well done. Great. Thank you so much. Which way is this open? Left and right or up and down? Good. Left and right.
Oh,
Oh, man.
I brought that answer from home.
Yeah, well done. All right, so I'll let you work on this for a little bit. I'll walk around. If you're having some problems, let me know. If you're watching this later on YouTube or something, then pause the video, finish graphing it, then come back.
It's like one of those cooking shows where they're like, where's the chicken in the oven and when we go back,
It literally
there's a
does.
whole ass turkey.
How's your back?
Same.
Same?
No, better.
No, better? Okay.
Thanks.
See? I would do that. Since you gave me so much.
Appreciate that. Does anyone want to borrow a ruler? On the test, I would greatly appreciate you using rulers to draw your asymptotes.
Oh, I'm good. It's making a straight line. Okay. I planned it out.
Yeah, I knew it was James.
Can I borrow your hand?
make it a big dot or something like that, if that happened on the test.
Careful not to curve away from the asymptotes, when you get closer to the asymptote.
Your power user. Should draw the Y ones, and looks like you have one, two, three. Should be. Oh, this. Alright, but this is not where you draw your lines. You draw it. You gotta put this one. I already did it. You draw it versus it to the right, to the left, and then up 3 down 3. So you draw a box at those points. Alright. It's actually better draw your asymptotes. And those should guide your graph. That's the reason for drawing these. You only plot points that are easy to plot at vertices. Other than that, plotting these points gets really hard. But we're avoiding that by drawing the asymptotes. We're just going to draw a curve that's close to, but doesn't quite touch the asymptotes. So, let's see. In the next direction. 2. 2 in the next direction. How far in the y direction? 3. So 1, 2, 3. So those points are going to be edges, or they mark the edges of our rectangle. Let's start with left 2, right 2, left 3, down 3, and drawing a rectangle through those points.
So the reason we put it in this form is so that we can graph this a little bit easier. It's going to help us find the edges of our rectangle. So in this particular case, I want to move to the left 2 and to the right 2, and then up 3 and down 3. So let's see if we can't do that. That's going to be about here and here. Let's see. These lines don't come out so wonderful. And then up 3 and down 3, so about here and about down here someplace. Oh, I can't really see. About there. Those are going to be the points that you would draw if this was an ellipse. And then you would draw in your ellipse in a nice circular path. How do I know that this is not an ellipse?
The minus sign.
The minus sign. I mean, there's not much partial credit I can give if you're drawing the complete wrong figure. So please make sure that you realize that if this is a minus, then your graph is going to be a hyperbola. Now, let's sketch in the edges of this rectangle. So down here, here. Now, why am I sketching in the rectangle? What does that give me? Yeah, it's going to help me find the, not the vertices, but the asymptotes. And the asymptotes are going to help me graph this. If you wanted to graph this by plotting points, it'd be a real nightmare. You'd end up with points that have square roots and there'd be really, really ugly points. It's just awful. We're avoiding that awful process by drawing in these asymptotes. And then we know that, all right, this is going to open left and right. We're going to have a couple of curves that start here at this vertex and open to the right, and another one that starts here and opens to the left. Now, what I'm looking for is a graph that kind of looks like, let's see, I'm going to try an orange. Yeah, I'll try an orange. This looks like this. It's going to get close to, but not quite touch the asymptotes. Don't curve back, don't curve away, because at that point I'll be tempted to take off points. The reason for these asymptotes is because the graph gets closer and closer and closer to them, but it doesn't quite touch them, like this. So if you accidentally touch it, that's fine. Just don't go crashing through it and don't ricochet off of it. The last but not least thing we need to do is we need to find the foci. So the foci are going to be given by c squared equals a squared plus b squared. In this case, 2 squared plus 3 squared equals 13. So c is going to be the square root of 13. Now those foci are going to lie inside each branch of the hyperbola. So here and here. Square root of 13, I don't know, I'm guessing about 3.6. Okay. So about 3.6, somewhere between 4 and 3. Square root of 13 and 0, and negative square root of 13 and 0. Diana, thanks for being spot on with that. There's your graph. Nice.
I have a question.
Yes, please.
Do you want us to mark the square root of 13 when we are in our graph, or are you fine with us just putting it on the side but still having our dot on it?
You're gonna have to do one or the other. It depends on, how much room I have when I write the test. But either just list what the foci are. I might have a blank at the bottom of the problem, so you can say, all right, here's the foci. And what I'm gonna want is exact numbers. I don't want the decimal values. I want exact things, which will include a square root.
Okay.
So it's either that, or maybe I'll just ask you to put it right on the test.
Okay.
Anything else for this one? Yes, Adam?
Do we have to find the equation for the asymptotes?
Not on this one, but, I guess it does ask us to find the equation for the asymptotes. So that's not too bad. Let's go back and revisit the little trick that I gave you just a little while ago, and that is to make the squared, or to make the 1 on the right-hand side equal to 0. So that would be x squared over 2 squared minus y squared over 3 squared equals 0. So in this case, because the y squared term is negative, I'd move that to the right-hand side. Can someone suggest a reason why I would move this term to the right-hand side like that?
Make it positive.
Yeah, it makes it positive. So I get x squared over 2 squared equals y squared over 3 squared. So looking good there. I can multiply both sides by 3 squared. Nothing wrong with that. That's going to be 3 squared x squared over 2 squared equals y squared. I need to solve for y. What can I do? Yeah, I'm going to take the square root on both sides. And in particular, on the left-hand side, I'm going to take plus or minus the square root. What's the square root of the left-hand side? I know I was going to have a plus or minus, but then what?
Square root of
Yeah, all these square terms disappear. It's just going to be 3 over 2 times x equals y. You can confirm that. So this has to be the positive one, y equals 3 halves x. This has to be the negative one because it has a negative slope, negative 3 halves x. You can confirm that by looking at this rectangle. This line which goes through the origin passes through this point right here, which is over 2 and up 3. Remember how you measure slope. The slope of a line is rise over run. So another way you could do that, if you wanted to find the equation of this line, is just say, okay, the slope is over 2 up 3. There it is, 3 over 2. And your equation of the line has to be y equals mx plus b. B is 0 since it passes through here. So that's another way to find the equation of this. It's just look at the slope of the line that goes through that corner. Adam?
Yeah, so, could you not just do like b over a to the slope?
Yeah, I mean, that's about what it amounts to.
Because like, I feel like even the last one worked as well, like you should do 3 over.
Yeah, it's just your b over a has to come from whatever's underneath the y, that's your b. Whatever's underneath the x, that's your a. So if you just wanted to keep in mind y equals plus or minus b over a times x, that's great. But that's the denominator from y, that's the denominator from x before you square them, okay? All right, good observation. Thank you. Anything else on this one? All right, let's put this one to bed.